And so for this practical, we have 80 watt solar panel in two places, making total of 160 watt solar panel. We also have charge controller. This is 30 amp. This is 30 amp solar charge controller, and the type of charge controller is PWM charge controller. Charge controllers are used to protect the battery from getting overcharged, and likewise from getting over discharged. Solar charge controller can also stop reverse loss of energy from battery back to the solar panel. So like we said earlier, we have two types of solar charge controller. We have the PWM solar charge controller, and we also have the MPPT solar charge controller. The MPPT solar charge controller are reserved. They are reserved for large solar installations. If your system is below 3.3 kVA or 3.5 kVA, I can recommend a good PWM charge controller. But if your system is anything above 3 kVA, MPPT solar charge controller is strictly recommended. So for the purpose of this very small practical project, we are going to be using the PWM solar charge controller. So for this project, we shall be using the 60 amp tubular battery, and we have said earlier in the earlier part of this course, we have different kind of batteries. We have the lithium battery, which is very much used in solar system. We have the lead acid battery, and we have the solar or wet cell we have the tubular or wet cell battery. Now the tubular or wet cell battery work with the same almost the same chemistry like a lead acid battery. So what it means is that with this 60 amp battery, we cannot use more than 30 amps, because for every lead acid battery you cannot discharge it more than 50%. So if you have a 60 amps battery, just take note that your battery capacity is half. If you have a 100 Ah battery, just know that you can only use 50 Ah. And if you have a 60 Ah battery, you can only get 30 amps out of the battery, 30 amps in hour out of the battery. So this 60 amp battery can conveniently give us 30 Ah battery capacity, because if we begin to use it below 50%, definitely if our battery is supposed to last let's say 2 years or 3 years, we may not be able to use the battery more than 8 months to 1 year. I want you to take note of this. If you love to enjoy to completely drain your battery and get it back to full charge constantly, then you will have to consider a lithium battery. And I must tell you at this junction that lithium battery is still very much costly presently. This project is taking place in Nigeria, and when I say the battery is costly, believe me, in this part of the world, lithium battery is still very much costly. So with a lithium battery, you can get your battery discharged to 0% and get it back to full charge as many times as possible. This is not a lithium battery, so let's just proceed with the project. The next gadget we shall be needing for this project is our inverter system. Of course, the energy from the solar panel and the battery, you cannot use it to power your alternate current AC device directly. So you will need a gadget that will convert the DC energy from the battery and the solar panel, that will convert the energy to AC current, alternate current, which can power our light, our bulbs, our TV, our laptops, and other gadgets that we are using in our homes. This is solar mounting. Solar mounting is extensively discussed in our solar master class. You have several options for mounting your solar panel. You can mount your solar panel on the rooftops. You can make up to mount your solar panel on an open space with the help of floor grounding mounting gadgets. Immediately after mounting your solar panel, next aspect, which is installing your solar charge controller. We have discussed how to install a solar charge controller on a wall. You may need to go back to the aspect of the course. So for this project, we decide to mount our charge controller on a board, a face board, so that we can just screw the charge controller directly on the face board. So now our charge controller has been mounted. We have some other thing mounted on the board. We have some fuse box. The charge controller, we have 6 connecting points, and each 2 point has a negative and a positive. And from the left side, we have our first 2 points, which have the negative and the positive point for connecting our solar panel. From every charge controller, you will definitely see the solar symbol on the side of the charge controller where you will connect your solar panel. And of course, the next two, the one in the middle, is meant for connecting the battery. So the next 2 connecting point on the charge controller is meant for connecting the battery. We have the negative point and the positive point, and you will see the picture of the battery in the next 2 points, the middle 2 points of the charge controller, which is meant for connecting the battery. And of course, we have the last 2 points by the right side, which is meant for connecting our load, which is DC load, 12 volt DC load, 12 volt DC load output. So now let's go back to the solar panel connecting point. We have a fuse isolating box that is connected directly to the solar panel. What it means is that the solar panel will be connected to the isolating box, and from this isolating box, it will be connected to the charge controller. So this serves as a protection for the charge controller. So if a very high current that is more than the power of the charge controller is coming from the solar panel, the isolator can stop it, can cut it off, and protect the charge controller and the entire system. Likewise, the isolating fuse box is also connected to the battery, which means the current between the charge controller and the battery is also protected. And of course, when we are sure that our system are properly protected by the isolating fuse box, we can pick our connection directly from the charge controller to our DC gadgets. There is another isolating fuse box for the inverter system. The inverter output goes out from the inverter and pass through the isolating fuse box before going out direct to our AC gadgets. The use of correct type of cable is important and in solar and inverter installation. And in this system, we shall be using the 4mm cable. Another part of the course is dedicated for solar and inverter wiring selection. The 2 solar panels will be connected in parallel by just connecting the negative polarity of the solar panel from the first solar panel to the second solar panel, and the positive polarity from the first solar panel to the positive polarity of the second solar panel. The arms of each solar panel, which is 4 amps, will increase to 8 amps, and the solar panel will maintain its volts, which is around 17 peak volts. The battery, connect the positive terminal cable that is coming from the charge controller through the isolating fuse box to the positive terminal on the battery. Likewise, do the same for the negative terminal. Connect the negative terminal cable that is coming from the charge controller through the isolating fuse box to the negative terminal on the battery. Connect your inverter system to the battery. In this case, this is a 12 volt inverter system, 12 volt 400 VA inverter system. So just connect the positive terminal of the inverter directly to the positive terminal on the battery, and do same for the negative terminal. Connect the negative terminal cable from the inverter to the negative terminal of the battery. Connect the output on the inverter system to the AC output isolating fuse box. Then connect the output coming from your solar panel to the isolating fuse box to the solar charge controller. So now it is time to test our installation. So from the solar panel, we have an output that is coming, and the output will go through the isolating fuse box, then into the charge controller. So we have to on the isolating fuse box. So as you can see, the solar panel is generating 21.5 volts, but it's showing that our battery is absent. Always turn on the battery first. Always connect the battery to the charge controller first. So we are going to on the battery. So our battery is reading 12.7 volts, and from the battery, it means the battery come with full charge. Then we can come back to turn on our isolating fuse box for the solar panel. And as you can see, the solar panel is reading correct reading now. The solar panel is connected to the battery, and the battery voltage will begin to increase, which means the battery is charging. We can on our DC load, and we have a bulb, and the bulb is on. Likewise, we can on our inverter system for the AC gadget. So now if we put on our isolating fuse box for the inverter output, this will send current to our AC gadget, and we also protect our AC gadget. And if we turn on our switch for the AC load, there is a bulb that is connected, and we also have a switch that we can use to power other gadgets. Put AC power supply to our AC gadgets. And our project, a very mini project, is working perfectly, which can supply a DC bulb. It can supply power to a DC bulbs, and also we can have power supply from the inverter to our AC gadgets. So this will be all for this project. Some other thing that we need to do is to knit your work, to keep the solar cable close, and to give it a root that will secure the solar panel. So this will be all for now. We will see you in the next class.